All right, let's solve some logarithmic equations. So to solve log equations, we could pretty much just write them in exponential form and go from there. So questions are going to be a little complicated, but in these two examples, you have one log on the left side. So we have, in this first problem, log, the base is 10 because nothing's written, of 34 minus 6x is equal to 1. So our base is 10. Our exponent is 1. And that's going to equal 34 minus 6x, that entire quantity that's in parentheses. So now we could just solve this. 34 minus 6x, subtract the 34, divide negative 6. So this first answer is going to give us positive 4. That would be our answer. You can plug in 4 and check it. When you check it, you'll get log of 10 equals 1, which is the case. All right, next one. Here we go. So same situation. We have our base. In this case, it's telling us it's 27. Our exponent is going to be 1/3. And then that's going to equal 3x minus 1. Again, that whole thing is in parentheses. So we're pulling out the whole piece like that. 27 to the 1/3. So because our exponent is a fraction, we write this as a cube root of 27 to the first power. The cube root of 27 is 3. So we simplify that and then we just go from here. Add 1. So the second problem, our answer is 4/3. So this is pretty much how you solve log equations. Now, if there's multiple logs on the same side of the equation, like this, what we do is we first need to combine our logs. So similar to linear equations and everything else, you always want to combine like terms first. Because there's two logs being subtracted, we could put them together. When we subtract exponents, we divide terms. Divide terms, subtract exponents. So we can write this as log. Again, the base is 10 because nothing's written. This is 5 divided by 2x. And that's going to equal 1. Now we can convert this to an exponential. 10 is your base, 1 is your exponent. 10 to the first power equals 5 divided by 2x. From here, we can put the 10 over 1 and cross multiply. So 20x equals 5 divided by 20. So we get x equals 1/4. And that would be our answer for this one. The only other type of log equation that you might get is if you have something like this, where it's log of, we'll just use the same numbers, 5 equals log 2x. So you have two logs on different sides of the equation. This is done the same way you solve an exponential with a common base. So both of these have the same base 10. So logically, if these parts of the equation are equal, that would result in these pieces of the equation also being equal. If you do the whole exponential thing, it pretty much results in something like this. If you raise them both to the 10th power, so you raise them to the 10th power, and what that essentially does is it gets rid of your log. The 10 and the log 10 cancel. Those are inverses. 10 to the log 10 cancels. So what you're left with, again, is just that 5 and that 2x. So you get 5 equals 2x. And then you would just solve it like that. So when you have multiple logs, they're either on opposite sides, where you would do something like this if they're the same base, or they'll be on the same side. So that's how you solve most log equations.